Hello everyone. In this question, it is given that if I of x be the integral of square root of x plus 7 upon x times dx, and I of 9 is equal to 12 plus 7 log 7, and I of 1 is equal to alpha plus 7 log 1 plus 2 root 2, then we are asked to find the value of alpha raised to the power 4. Okay, so we are given a function I of x, which is the result of the integral of square root of x plus 7 upon x dx. Okay, and after evaluating this integral, we are given the condition I of 9 is some value and I of 1 is some value, and from these two equations, first we need to compute the value of the constant of integration, that is capital C, and then we need to solve this alpha. Okay, so we have to solve two simultaneous equations. Okay, so let us first start. We are given this integral square root of x plus 7 upon x. Okay, so let us try out the substitution of, let this square root of x, let this square root of x be u. Okay, so from here, if root x is u, then x will be the square of u, right? So this will be u square. So now if we differentiate both sides, we get dx is equal to twice u times du. Okay, so this integral now changes from square root of x is nothing but u square, right? So this becomes u square plus 7, and this x is again u square, right? Times dx will be nothing but twice u, this is in the rough, okay, twice u times du, right? Okay, so see, in the denominator we have a perfect square u square, right? So we can take that out of this square root, so we are left with u square plus 7 under root in the numerator upon u times 2u du. So we see this u and this u cancel each other. Okay, this u and this u cancels each other, so this now becomes integration of u square, and this 7 can be written as square root 7 whole square times du, right? So again, this integral is now of the form of integration of square root x square plus a square, where a is some constant, okay, dx, and this is a standard integral, right, from integration by parts. So this integral, the formula is half. If you take half common, the result of this integral is nothing but x times square root of x square plus a square plus a square times log of the absolute value x plus square root of x square plus a square, right? So this is the formula. So I'm going to use here this formula. Here x is u and a is root 7. Okay, so on using this formula, this becomes, I think I have missed a 2 here, right? So there should be a 2 here. This 2 is left out, I missed it. Okay, so this is 2 times this integral. So if I use this integral, this formula in the right hand side, this becomes 2 times. If I take the half common, this becomes 2 times half, and this becomes x will be u here, so this is u times square root of u square plus a square will become 7 again, 7 plus a square will be just 7 log u plus square root of u square plus 7, and since it is log here, I'm taking the absolute value, okay, plus c. Okay, so I have just used this formula here. Okay, you can just cross check and verify if there is any mistake. I think it is correct so far. Okay, so this 2 and this half will cancel each other, this and this will cancel each other. So we have, I think, completed the integral. Now this integral, we have used the substitution u is root x, right? So since this is a function of x, I can do the back substitution. So if I do the back substitution, instead of u, I can write it as square root of x times u square will be u square is x, right? So this becomes square root of x plus 7 times log, this is again root x plus x plus 7, right, plus c. So this is the ix value, function of x. Okay, so now I'm going to use these conditions, I of 9. So if I put x equal to 9 in this equation, in the above equation, okay, here root 9 will be 3, right? And this will be 9 plus 7, which is 16. So square root of 16 will become 4 plus 7 times log of, again this is square root of 9 will be 3, and this will be square root of 9 plus 7, which is root 16, which is 4, okay, plus c. So this becomes equal to 12 plus 7 log 7 plus c. Now we are given the value of I9, right? I9 is 12 plus 7 log 7. So we already have this part. Okay. So this implies that I9 is equal to, this is the part which is given, right? This part is given already, 12 plus 7 log 7. So we have I9 is equal to I9 plus C. So this implies that the constant of integration is 0. Okay. So we have I of x equal to this expression without the constant of integration, that is constant of integration is just 0. So this is root x times root x plus 7 plus 7 log mod of root x plus 7. Okay, this is the expression for ix. Now if we place x equal to 1 for I1, we get root 1 is 1 again, and this is square root of 1 plus 7 will be square root 8, right? So square root 8 is nothing but 2 root 2 plus 7 times log of root 1 is 1 again, and this will be root 8. 1 plus 7 is square root 8, right? So square root 8 is nothing but 2 root 2. So this becomes 2 root 2 plus 7 log. Since this is a positive number, I am removing this absolute value, okay? 7 log 1 plus 2 root 2, right? Now what was the value of I1 which was given? It was given alpha plus 7 log 1 plus 2 root 2, right? So it was given that alpha plus 7 log 1 plus 2 root 2 is equal to this 2 root 2 plus 7 log. So we have already found the value of alpha from this equation, right? So this and this are same. So we get the value of alpha is equal to 2 root 2, okay, or root 8, whichever you prefer, okay? So alpha raised to the power 4 is nothing but root 8 raised to the power 4, which is equal to 8 raised to the power 2, right? So this becomes 64. So this is the required value of alpha raised to the power 4, okay? This is the required final answer. Okay, so this integration, we required this substitution here, but this substitution is not so difficult, okay? This is relatively like, usually in the first try, if you want to remove this x from under the square root, we'll try to uh, take the square as some variable, right? That is x equal to u square is the usually the first steps of substitution that we might try. So you can try that, and we get this u and u cancelling each other, and then this we can use this standard integral formula. Okay, you need to remember this formula, but these are part of the board syllabus also, and also the JEE syllabus. So this is relatively should be known, should be commonly used also. Okay, and the rest is just solving this two unknowns using these two conditions. Okay, so from here we first find the value of c, which is 0, and from the other condition we find alpha, and the rest is easy. Okay, so this was relatively not that difficult as far as integration is concerned, because integration is usually slightly difficult chapter in competitive exams, right? So this is it. Thank you for watching.